Sahiron, and I am going to discuss about the composition and structure of the Earth's atmosphere. And our objective for this discussion is to determine the structure and composition of the Earth's atmosphere. Next, to determine and differentiate the structure of Earth's atmosphere. And lastly, to appreciate the importance of the Earth's atmosphere. So here are the composition and structure of Earth's atmosphere. So first, atmosphere is a blanket of colorless, odorless, and tasteless gases, water, and fine dust wrapped around Earth. It is about 430 miles or 700 kilometers deep. It has no upper boundary and simply fades into space as it gets thinner. The atmosphere is an important part of what makes Earth livable. It blocks some of the sun's dangerous rays from reaching Earth. It traps heat, making Earth a comfortable temperature, and the oxygen within our atmosphere is essential for life. So here are the composition of our Earth's atmosphere. As you can see, the nitrogen composes the largest of our atmosphere. Next is the oxygen. So the nitrogen is 78% by volume in our atmosphere. Next is oxygen, which has 20%. Lastly, the hydrogen, which is the least. So the structure of Earth's atmosphere is composed of two. So this is our atmosphere looks like. So the layers of atmosphere is based on a composition and the temperature. So based on the composition of constituent, there are two layers of the atmosphere. The first one is the homosphere. The homosphere is the lower region extending from the surface of the Earth to a height of 80 to 100 kilometers above the Earth. The next one will be the heterosphere. Starts from the upper portion of the homosphere and extends to the height of 60,000 kilometers above the Earth. Concentration of gases keep decreasing as one goes up. The next one will be the layers of atmosphere based on temperature variation. So the first one is the troposphere. It is where all weather takes place. It is a region of rising and falling packets of air. The air pressure at the top of the troposphere is only 10% of that at sea level, or 0.1 atmosphere. So the troposphere, it is the layer of the atmosphere where the storm emerges. So as you can see in this picture, we can see that the troposphere is represented by a lightning and a clouds, which means that the troposphere has lot of clouds. The next one will be the tropopause. The tropopause is the upper boundary of the troposphere, and the temperature remains constant with the increasing altitude. The next one will be the stratosphere. The stratosphere is the layer of the Earth atmosphere where temperature begins to increase with height. Very stable as denser air is below less dense air, up to above 48 kilometers or 30 miles. Temperature increases as a result of interaction between high-energy ultraviolet radiation and ozone. So as you can see in this picture, the stratosphere, it is where the airplane pass through. It is because it has less number of clouds. So it also represented the ozone layer. So the ozone layer helps trap the UV ray that keeps us from the cancerous rays of the sun. So the ozone layer. So the ozone is very beneficial to human life. Next one will be the stratopause, where the temperature reaches a maximum of 10 degrees Celsius. The stratopause, it is the boundary of the stratosphere into the next or before the next layer comes. So the next layer will be the mesosphere. The mesosphere begins at about 50 km or 31 miles above the Earth's atmosphere or Earth's surface and extend to 80 km or 50 miles. So meteorite entering Earth's atmosphere usually burn up in the mesosphere. So the mesosphere, it is what we can see here. It is where the shooting star, or also called as meteoroid, burn up. It is because the gases interact to each other, that's why it burns up. Next one will be the ionosphere. The ionosphere is defined as the layer of the Earth's atmosphere that ionized by the solar and cosmic radiation. So it represents, or it includes the ions for our radio waves. Next one will be the thermosphere. It begins at 80 km or 50 miles above the Earth and extend outward into space. Temperature in the thermosphere can reach 1,800 degrees Celsius. The beautiful color of the aurora borealis or northern light occurs in this atmospheric layer. It is because the ions react with our magnetic field. The last one will be the exosphere. So the exosphere, it is the upper region of the Earth's atmosphere as it gradually fades into the vacuum of space. Air in the exosphere is extremely thin. In many ways, it is almost the same as the airless void of outer space. And that was our discussion about the composition and structure of the Earth's atmosphere. And I hope you've learned something. Thank you.